Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Good to see everybody. Let's just have a quick look and see who's around. Nobody at the moment. That's fine. But anyway, yes, I've got quite a few people here tonight. Thank you for joining us. Much appreciated as always. Doesn't seem a week since we were last here, but it is nonetheless. Been quite an eventful week in terms of space exploration and one thing and another, so we'll be discussing that later. Tonight, our main feature, if you like, I'll be telling you all about some bizarre moons of the solar system. We'll come to that a little later. First of all, I'd like to say hello to all the panel. So starting right up there is John. How are you, John?
All right, thank you very much.
Good. Pete, nice to see you again. How are you?
I'm fine, thank you. Just enjoying the lack of sun at the moment. But,
right.
Because remember, I live in Wales.
Yeah, I know.
A mile off Wales, so it rains a lot.
Yeah, of course. How was Portmeirion?
It was beautiful. Well, Portmeirion's always beautiful, isn't it? You know,
Yeah.
we were stopping in Portmeirion. It's great at night when all the day visitors have gone home and the bar opens and
fantastic.
yeah.
I'd love to
I need to say no more. Really, it's just stunning.
No, I'd love to go back there one day.
Yeah.
I haven't been there for years, but lovely. And we welcome from the United States, Aaron. How are you, Aaron?
Very good. Thank you. It's good to be back again, and hopefully things will work a little better tonight. I seem to have no end of hardware issues. But actually, I wanted to just comment, I'm doing much better because for the last 2.5 weeks, my observatory has been at 95 degrees Fahrenheit, and they finally fixed my air conditioning.
Wow. I bet that's
so I'm doing much better.
Yeah.
Good. Well, lovely to see you again and welcome. Gerard, thank you so much for your generosity, sir. Already straight in there. Thank you. As you know, if you want to support Space Oddities, you can click the super chat button underneath the chat window if you want to make us a donation. If you would like to buy us some coffee, then you can, and this is how you do it. You scan the QR code, and that will take you to the hello.
Oh, that's all right. It's me. I'm trying to get.
Right. Can you just get rid of that?
Yeah, I'm just doing it.
Spoiler alert.
You can scan the QR code, and that will take you to the Buy Me a Coffee page, where you can buy us a coffee for a small fee, and all money that we receive goes towards keeping the channel going. Let me just, there we are. That's better. Thank you, Daz. And that link will have just popped up in the chat as well, so you can buy us a coffee. Much appreciated. Or you can use the super chat. And thank you very much for your generosity, guys, as ever. So just the usual bit of housekeeping. Don't forget the summer collection from the Space Oddities merchandise is now available, as it has been for a long time. Of course, all our merchandise you can peruse at your leisure at the Space Oddities shop. Again, you can scan the QR code or click the link that's just popped up in the chat. And we've got T-shirts and hoodies available. We've got long sleeve versions of some of them. We've got lapel designs. Go and have a look. It's all there. And again, all helps to keep us going. So there we are. So what else has been happening? Well, we're going to have a chat about what's been happening in space with the, shall we say, ill-fated Lockheed Starliner. Because that's been major news this week, NASA having to make the decision about what to do with what the media have been calling the stranded astronauts, although they've never been really stranded, but I suppose it sells column inches. And the decision has been made by NASA, and we'll be talking about that a little later. What we're going to do in a break with tradition is go straight to the news this evening. And just a few things in the news. It's been a bit of a quiet news week, I guess, because it's August and a lot of people are on holiday and news isn't flowing to the same degree that it normally does. However, let's go and have a look at the news. Let me get myself sorted out here. And The first story concerns India's Chandrayaan-3 lander. Now, you may remember that a year ago now, Chandrayaan-3 touched down on the moon. Great triumph for the Indian Space Agency and Indian science in general. Touched down not too far from the south pole of the moon. And it released a little rover onto the surface. And that rover made quite an interesting discovery. And the discovery is that the soil that it examined has it's primarily made up of a white rock type called, and this is a rock I'd never heard of. Perhaps anybody on the panel can enlighten us if they've heard of this. It's called Faroan anorthosite, and this is a white rock that was strewn in quite large quantities around the area. However, why is that important? Well, you see, they've compared this to samples collected from other regions of the moon, in particular from Apollo 16 and the Russian Luna 20 mission, which also flew in 1972. And they've compared the lunar regolith, or the lunar soil, if you like. And what they found is that they've all got this white rock called Faroan anorthosite. And what that has led them to conclude is that this all came from a single magma ocean that covered the surface of the moon in the very early history of the moon. Now, this had been predicted or surmised that at one point the moon would have had a magma ocean on its surface, but this is the first direct evidence that it did. And, we don't really know that much about the early history of the moon. It's a bit of a puzzle to untangle. So this is good news because it confirmed what some scientists were saying. And now we seem to have the evidence that in the moon's early history, that it was covered with a magma ocean where all this rock came from. So that's quite interesting this week. Also, this beautiful.
Sorry, Andy. What was that called again? Faroan
anorthosite.
Anorthosite. Good game. Good game.
Yes.
Sorry, that was sad.
This beautiful image has been released to coincide with the 25th anniversary of the Chandra orbiting X-ray observatory. Anybody like to guess what this is? Let's see if any of the panel can identify what this is.
Looks like a colliding galaxies.
Looks like some kind of lizard.
The
big eyes.
Anybody? No?
Oh, it's not it's not Andromeda, is it?
You're quite right. It's not Andromeda.
Okay. See, I told you I was right. The only other thing I can think of is what's that? That 5, the quintet.
Stephan's Quintet.
Yeah.
Yeah. No.
Yeah. No. God.
No.
All right, I give up.
All right. So, viewers, over to you. Do you know what this is? Quickly put it in the chat if you've any idea what we're looking at. It's an X-ray image from NASA's orbiting Chandra Observatory. Don't forget the one that NASA have said they're canning in a few years' time to the utter dismay of X-ray astronomers everywhere.
They're on the Chandra site right now trying to get the answer.
Right. Yeah. Has anybody put anything in the chat? I can't see the chat at the moment.
Not at the moment.
No guesses? No guesses.
No.
We're not offering a prize for this. What you are looking at is the center of the Milky Way in X-ray.
Yeah.
Oh, that was my next guess.
Yeah, right. So let me just identify a couple of things for you. The very, very bright spot at lower right, that is Sagittarius C. That is an intense star-forming region. It's very, very bright in X-rays. The object in the direct center of the image, that is the supermassive black hole at the center of the galaxy, Sagittarius A star, in X-rays. It's very bright in X-rays, as you can see. And all of these different colors are different intensities of X-rays. Now, on the other hand, if you look at the same area in radio light, this is taken from the Meerkat radio telescope in South Africa, which, as you may know, is a precursor telescope to the Square Kilometre Array when it's completed. This shows the same area in radiolite, and you see these sort of tendrils going vertically in radiolite. Nobody knows what they are or how they got like that, but they are associated with, they think, that supermassive black hole in the center of the image, which is very bright in radiolight as well. Now, by the miracle of technology, we can actually combine those two images to come up with this amazing picture. So you're looking along the galactic plane, and you're now looking at radiolight and X-ray light. And just put a key up on the screen for you that I did. So orange, blue, green, and purple are X-rays, different intensities of X-rays, and the lilac colors are the radio waves. So I just thought I'd show you that because I think it's an amazing image. Another amazing image that Chandra has come up with is the Crab pulsar. That is the fast rotating neutron star at the center of the Crab Nebula, which is this, again, in X-rays, which I think is quite a remarkable image. And NASA have released many images to coincide with the anniversary, the 25th anniversary of Chandra, which is a bit ironic considering they're cancelling Chandra because of budgetary constraints, which many people are protesting about. When it can deliver images of the Crab pulsar like this, it's amazing. It's an amazing image. And don't forget that we don't have another X-ray observatory in orbit to replace Chandra, not at the same wavelengths. So this is a real shame. So if you can track it down, there's a petition on the web. I should have looked up the address. I didn't. I'm sorry. There's a petition on the web to stop NASA cancelling this amazing telescope, which they plan to do in 3 or 4 years.
Yeah. Just a quick one, Andy. Did I read somewhere quite recently that they reckon there could be a second black hole at the centre of the Milky Way?
Yes, that was an idea, but the observations don't support it.
Right, okay. No, I just thought I read somewhere.
It was an idea, but there are no emissions that would indicate that's the case. So
right, okay.
We can put that one to bed, I think. Next up is a video of the COF Boeing Starliner in orbit with an aurora in the background. And I just wanted to show you this because I thought this was absolutely beautiful. And if you look at the window in the Starliner, you can see Butch and Sunny in there in a second. So there we are.
What are they doing? Welding?
Yeah, they are. Yeah, you'll see the bright flashes in a moment of the.
That's one way of fixing the lid.
They are.
Oh, there we are.
Yeah. So I don't know what those flashes are. I don't know what the hell they're doing in there. But perhaps they've got a really bright torch and they're trying to find the correct button to press to make the damn thing work. So there we are. But I thought that was just a lovely video for that. And as you may be aware, we were intending to bring you live coverage of the Polaris Dawn launch tomorrow. But unfortunately, because of a helium leak in the ground equipment, the launch this morning had to be scrubbed. We are going to bring you the live coverage tomorrow because it's been delayed by 24 hours. Starting at 08:15 BST, we'll be here bringing you live coverage. And I just thought I'd play the video that's been playing on the channel over the last few days, the objectives of the mission and who's actually flying on it. So for the next 3 minutes, you can just sit back and relax, and off we go. Okay, so there we have it. So that's the news for today.
Indy,
Yeah.
Sorry, can we remind viewers exactly Polaris Dawn is obviously a privately launched mission, or is it backed up by any space agency?
It's the second fully commercial mission that is being launched by SpaceX. The first one was Inspiration 4, as it said. Excuse me 1 second. 1 second. I'll be back in 1 second. Sorry, this is
all right. Okay.
Okay.
Well, shall we sing a song, Gus?
Yeah. Who can do some mime or something?
We went into a bit of a disco mode at some point with that music.
Yeah. Did you actually hear any music? I could hear some.
I did, yes.
Just a little bit.
I could hear music, but it sounded like it was being broadcast underwater.
Yeah.
Yeah, sorry about that. That was my daughter. Obviously, I need to answer her. So it's the first one was Inspiration 4, which was the first commercial mission launched. And the one of the objectives was to raise money for St. Jude's Children's Cancer Hospital, which is one of the world's leading juvenile cancer research hospitals. And that mission managed to raise $250 million for the hospital, and they're going to try and surpass that with Polaris Dawn. But Polaris Dawn, as it said in the video, is a very, very important mission because it's going to try things that have never been tried before. That is to say, the highest orbit ever attempted around the Earth by a spacecraft, something like 1,400 kilometers away from the Earth. And also, we get a spacewalk. The commander, Jared Isaacman, is going to do a spacewalk out of the Dragon capsule, adorned in the new SpaceX spacesuit that they designed and built. They're going to be carrying out, as it said in the video, loads of medical experiments into all sorts of things. So this is a really innovative mission. It's only the second of its type. It's the first Inspiration Dawn missions. It's the beginning of the real Inspiration missions. They've got 4 of these missions planned in total. And hopefully the last one is going to be on SpaceX's Starship. By then, we hope that the SpaceX Starship is going to be operational. So lots of exciting things coming up in space. And it just shows how much the commercial sector in space has grown. And in fact, at the moment, with NASA in such trouble with Starliner and SLS and lots of other things, the commercial sector is really starting to dominate in a way that it's never been possible to do before. So there you are, Bernard. Does that answer your question?
Yeah.
Yeah,
Yeah,
no,
'cause you were
totally.
saying, sorry, you were saying about the distance it's going to travel. It's 1,400 kilometers,
Mm,
which actually breaks the record. The previous record holder was Gemini 11,
that's right.
but the actual thing that holds a record for the furthest thing man capsule from Earth was Apollo 13.
Yeah.
So, but of course, that was them looping around the moon. I
Yeah.
think that distance has been surpassed by Orion, wasn't it? But of course, there was nobody manning it.
No, that's
So,
right. That's right.
yeah.
So
So, yeah.
it's technically the furthest manned or crewed orbit from the
Yeah.
Earth. So so there you are. Is everybody excited about this? Because I am. It's going to be an amazing.
Oh, I am. Yeah.
Yeah.
And I'm particularly looking forward to watching the spacewalk live. We will try and cover the spacewalk live as long as it doesn't happen in the middle of the night or something. But
If it happens in the middle of the night, I'll be there. I'll
I
put
think
it
I
on.
will
Don't
be
worry.
as well. Actually, the question is, will our viewers be? That's the real question.
Yeah.
Because one of the things they've got to do, I don't want to go into it too much, but literally from an hour after they actually launch,
Mm.
they then have to go into a breathing routine, which will actually stop them from getting the bends when they actually do the spacewalk.
Yes.
So literally right from the get-go, because the spacewalk is day 4, I do believe.
Yes, that's right.
But from the get-go, they've got to get all the nitrogen out of their blood to make sure that they don't get the bends. So,
Yeah.
which is, of course, which you associate with deep sea divers. But
And this is one of the things, of course, that they're researching.
yeah,
As it said in the video, this I forget what it's called, but it's to do with the formation of gas bubbles in the bloodstream. So this
How long
is
is the mission lasting for?
5 days.
well, they come back on the 6th day. Yeah, this is
Yeah.
The other thing,
on the 6th.
the other thing about the spacewalk as well, as there are probably going to be 2 people outside, the whole crew will technically be on the spacewalk because they have to depress the whole capsule for the egress.
There's no airlock. Yeah.
No airlock, yeah.
But not forgetting the crew of the Boeing Starliner are constantly depressed.
Oh dear. Oh dear.
Yes, that's right. They have
Bit of a
to
dig.
decompress the Dragon because there's no airlock, of course.
Yeah.
Let's
they
just
all
hope
have
they make
space
sure
in
they've
them.
got everything nailed down, because I always remember
Yes.
the first American spacewalk, and one of the things you see fly out is one of his gloves, spacesuit gloves.
That's right.
So yeah, I hope they got everything nailed down and everything stowed away properly. But yeah, they all officially will be exposed to the environment of space.
Yeah, that's right. That's right. Anyway, so that was the news. As I said, not much news this week, but there we are. So I think we'll press on and go over to Roger now, if he's ready.
I am.
Okay, let me just do the business here.
Right.
Okay, so I don't know if you've got much of a gallery this week, Roger.
We have a smaller number this week.
Yeah.
But
People
I did
on holiday, I think.
I did add a few due to the occultation of Saturn, and
Oh, yes, of
you'll
course.
see all those things as we go through. So
Right, take it away.
take it away. Okay, so we're ending August and starting into September. 1st of September being the first day of autumn in somebody's calendar or other. So there we go. Right, we're heading on our way from the last quarter through to a new moon on next Monday. So things might not be so abstracted. This was what the moon was like this morning, about 5 o'clock.
Oh, lovely.
Looking rather demure up in the night, up in the sky, and it's
Demure.
you almost have to creak your neck to look up at it at the moment. It's up to about 66 degrees at its highest point in the sky, but that's obviously later about midday or so. So there we go. This is what the sun was looking like yesterday. Left to right being white light, calcium, and then hydrogen alpha. with a rather interesting suspended prominence there, which I think did have some arches linked to it at a later stage, but not obviously when I captured this picture. I was rather intrigued by the image that I got in the calcium, which you can see, and then switched over to the hydrogen alpha to get a better detail of it.
Yeah, well, just wait and you'll see a bit more of that.
Yeah, I know. Anyway, so we've got Saturn in the night sky coming up quite nicely then, and we've still got the summer triangle, which is now going over towards the southwest. So currently we've got Andromeda and Pegasus sort of dominating the southeastern skies. And later on through the night, you can start to see the Pleiades and the winter constellations coming up through. So things are moving apace now as we get into September. So that's not looking too bad. And this is at 3 o'clock in the morning, only 3 hours after the sequence that I've just shown you. And as you can see, Orion coming up nicely. And then through Taurus, we've got Uranus, Jupiter and Mars coming up through, and some quite nice photo opportunities there. And we did have the moon fairly close to the Crab Nebula, which is in a couple of nights' time. So good opportunity there for a reasonably wide-angle shot to capture those two subjects, if you can get the clear skies, which there might be a good opportunity during Wednesday night, hopefully. And just before sunset this week, we have got Mercury, which is now heading rather low, so it will be becoming a morning object soon. But Venus is still quite close to the sun, but you should still be able to see it, although it will need a good low horizon to be able to see it, as it's not too far above the horizon once the sun has set. But any opportunity is a chance. Okay, so I've just got Shunazan Atlas up on the screen here, just in case anyone is still following a comet. It's moving through sextants now, and it's still behaving reasonably well, although there has been some recalculations on the magnitude down to about magnitude 2 or even 3 now at its maximum, which is a lot fainter than the minus 0.2 that they were forecasting. But it's still brightening up. By the latter part of September, it's down to magnitude 4. So we'll still see if it holds well to the present calculations on its brightness. And of course, last week we had the occultation of Saturn. These are a couple of images that I managed to get just as it went down behind the moon. The clouds came over, but I just about caught it in time. And obviously, I didn't get the exit point because the trees were in the way. But at least I managed to get it fairly close to the occultation, as you can see there. And then just as that was the last frame that I could get, and then the clouds came over. So I was lucky to get that, really. But pleased to be able to see it. That was the main thing. We do have an image from the James Webb. This is from the Cosmic Evolution Early Release Science Survey, which is what the Sears is from. And that is roughly at a distance of 13 billion years away on the light scale. So obviously still finding lots of interesting distant regions of galaxies to see, as you can see from all the red shifted galaxies there in the picture. So more and more that they keep finding. Okay, so we're onto a gallery. Not quite as big as last week, but we still got people subscribing into these. And these were just some images of the moon that I did during the week. And These were just stacked pictures using Sharp Tap's live stacking tools, and they seem to come out quite well. You don't have to process any video files to get the images. It just keeps stacking them up, and got some reasonable seeing and got some quite good clarity shots there. Obviously, the one on the left, if I blew that up, it was illuminating Apollo 15's Hadley Rille up quite nicely from the western side for a change, and it was quite good to see. And then I turned my eyes over to Jupiter, excuse me, and Mars. As you can see, Mars is still only a matter of 6 or 7 seconds of arc, so you really need a good long focal length to get some good clear views with some good seeing. But that's as good as I could manage at the moment, but not too bad. And there is this image. This might be a bit controversial. In fact, due to the fact that it's a composite, but the picture of the moon with the 7 sisters was in its right position. It's just that I just couldn't get enough of the Pleiades to come up clear enough to be able to show you that it was near the Pleiades. So I just reinserted. Both the images were taken with the same setup, so it is the right scale for where it was. Although a few hours earlier it was more over to the right, but that does give you an idea of where it was when I actually saw it.
That's not bad.
Even though it isn't the actual picture, the moon glow is just so overwhelming that you just couldn't get anything else. It would be just a white background if you tried to get the stars there, but it was what it is. Anyway,
amazing shot.
This is a another Saturn Moon conjunction that Daz took on his Sea Star, and as you can see, he did manage to get Saturn there. Yeah. Although trying to compensate for the comparison brightnesses is rather much of a challenge, like I had with the previous picture.
Especially on the Sea Star, you have got some adjustment. But the thing is, looks so white, and that's because the clouds were already coming in for me. So I was really surprised that I got anything. And what I did in the end, because I started taking images of the moon, and I thought, well, I was actually watching it with binoculars to begin with. So what I thought I would do is I said, well, let's have a go with the Sea Star, see if there's anything that I can do. And luckily I had about 15 minutes before we got to this stage. And what I found was that if I just took a normal picture, you could, if you knew where to look, you could actually see Mars, but it was so faint. So what I had to do is literally adjust the brightness so that basically the moon was basically, as you can see, it's virtually blown out. But it actually brought Saturn out. And then what I did is I sort of like took some pictures and all that. And of course, because I was still messing about with it, but every time I messed about with it, the autofocus, when I tried to, if I zoomed in or whatever, the autofocus was beginning to focus on the clouds rather than the actual thing. So I kept losing it. So in the end, I managed to get it. I just left it alone. And I thought I'd just start a video and then just see what happens. And to be quite honest, I'm really chuffed that I was able to get it with the Sea Star.
Yeah.
I mean, of course, it looks like the rings are far more open, but of course they're not. That's just where the actual Saturn's been blown out. But it just goes to show, put your mind to it and have a go, and it's surprising what you can get. But what made me laugh is I came back in, I posted it straight on Facebook, and within seconds I was getting replies. Apparently everybody else was out doing it, but of course their pictures were far more superior, like yours, Rog. But it's Saturn being just about to be occulted by the moon. So I've got it in chat. So I was chuffed a bit.
Chuffed a bit. You did well. You did well.
Very well.
Thank you.
Yes. Right, so we're over to Ireland for Michael Murphy's picture of the sun. And this is what he has managed to capture.
Oh, nice.
A very active sunspots there. Yes, very good.
Well done, Mick.
You did all right there.
Yeah.
Is that upside down? Yeah, it must be.
I think it needs to be flipped
It
over,
needs to
doesn't
be
it?
flipped over, yeah.
Flipped over, so it's north is at the top.
I just suddenly
bottom.
thought, why are all the sunspots in the northern hemisphere? Yeah, which is the sun's the opposite at the moment. Yeah, no, it's a lovely picture. I really do.
Lovely picture.
So yeah,
certainly,
beautiful.
certainly
if that's of course, if that's through a telescope, then it would be.
Yes.
So yeah.
So we've got one from Jerry of the Eastern Veil and Bat Nebula with his usual equipment, and this is what he's produced.
Oh, that's nice. Lovely.
That's lovely.
Wow.
Well done, Jerry.
Great.
I could never quite see the bat, really, on that, really.
No.
Although I suppose I can sort of see some pointy ears at the top bit, but it can be a bit vague.
Lovely image there. Beautiful.
Oh, yeah, I can actually
got
see.
some nice colour details there.
Yeah, if you look to where the main body is, if you follow it up to the very top, at the bottom it looks like two legs. It's very narrow, and then get to the top, and you can see a face and some. I can say, I see it now. That's the first time I've seen it as well, Roger. Oh, sweet.
Anyway,
okay. Thank you all very much for your contributions. Don't forget that if you would like to send us your images, you can pop them in an email and address the email to spaceodditieslive@gmail.com. And one image per email, please. And if you could manage to put the word gallery somewhere in the subject of the email, it'll be picked up by the Space Oddities elves and shoved Roger's way so that it doesn't get lost. So thank you very much. As we always say, we do love looking at your images. Please keep them coming because, you're all very clever people. And I can honestly say, and I think everybody here would agree with me, I don't think we've ever been sent an image that was crap. I think every single image we've ever received has been absolutely wonderful, and we're happy to show them. So there we are. Okay, I'm going to move on now. I'm going to talk to you this evening about some moons of the solar system. Obviously, not all of them. Here's a question for the panel: how many known planetary moons are there in the solar system? Anybody want to have a guess?
By the time we give you the answer, there'll be more with those chaps on Hawaii. Find them every 5 seconds. They will get a proper job.
How about 206?
206.
234.
134.
I'll say 300 on.
300.
120.
I'll go 350.
Aaron, any idea?
I can't talk.
Oh.
121.
We can hear you, Aaron.
Oh, you can. Well, my thing says I'm muted. I could have answered the question if you'd asked me how many total moons do we know about, but I don't know the number for the planets.
Right. Okay. So the actual answer is, let's give the viewers a chance to answer that one quickly. If you want to have a guess, how many planetary moons are there in the solar system, and see if anybody can hit it on the nose. Derek says thousands. Yeah.
That's hedging your bets, isn't it?
Yeah.
We haven't heard from Pete or John.
No.
121.
121.
270.
270. Bernard.
I said 234.
234.
This is like guessing how many sweets are in a jar, isn't it?
Yep.
How many moons in the
prize
solar?
for this, but it might be interesting to know that there are actually at the moment 293 known planetary moons in the solar system. Kev says 325. You're very close. Stuart 487, not close. But there we are. And as we know, there are new moons being discovered in the solar system all the time. Does anybody know how many known moons there currently are of Saturn?
62.
62.
No, there was more.
Yeah, I'll go with 6. I'll go with 67.
Right.
120.
78.
142.
142. Right, I'm going to give that to Aaron because the actual answer is 146.
Ooh.
So you were very close, Aaron. Yes. And Jupiter has a lot less. Now, you may remember, those of us of a certain age, when I was young, Jupiter had 12 moons and Saturn had 9.
I remember it well.
Yeah. Saturn now has 146 and Jupiter has 92. So there we are. So I'm going to talk about some of these moons, the more bizarre ones and why they're bizarre. And they're just ones that have struck me as being very strange for different reasons. And as we know, the moons of the solar system are sort of extremely varied. And they all have stories written upon their ancient surfaces that we're only just beginning to be able to interpret. And they do speak of lots of things, but we'll come to that a bit later. So just let me get myself set up here. And
Andy, while you get yourself set up, can we clarify what is the definition of the moon? At what point does the diameter of a body reach a point where it is a moon or where it is not a moon?
Oh, I can address that one.
Yeah, Aaron, please.
Yeah, there is no diameter requirement. What the only requirement that normally is used is it has to be in a fairly stable orbit, so it's going to be there for a long time. So asteroids that may come in, orbit a little bit, and then leave again don't count. But anything that's orbiting a planet, or actually any other body in the solar system, counts as a moon.
So there you are.
So let's say we see something that's the size of my car orbiting Jupiter, that's going to be identified as a moon. Is that correct?
Yep.
Right.
Yeah.
We're
Yeah,
gonna
at
find
the
those.
moment,
And by the way, when I say planetary moons, of course, I specify planetary moons because, of course, we now know lots of asteroids have little moons orbiting them.
Yeah.
And we don't know how many there are of those. We definitely hundreds, maybe even thousands. We don't know.
yeah, because the definition is going to be set later this year, isn't it?
Yes.
They're doing a
that's right.
redefinition, so then it's going to be done, I think, en masse.
Yeah.
I think in that respect, we'll wait until they come up with it, because the definition of a moon is not very clear at the moment.
No, that's right. So I hope you can all see that. Let me just go back into it here. All right, so I want to take you on this tour. Everybody can see that, can they? Moons of the solar system? Okay. Right, so you've got Mars. I haven't written 2 known moons because we know that Mars has 2 moons, and it's extremely unlikely now that any more are going to be found after all the exploration of Mars that's gone on over the last 50 years. So we'll say, of course, you can never say never, but Mars probably hasn't got any more moons than 2. Then you've got Jupiter with 92, Saturn with 146, Uranus with 28, Neptune with 16, and Pluto with 5. Now, I'm not going to talk about Earth's moon. I'm not going to include that. Very interesting though it is, because I think, there's been so much talked about it. I'm going to start with Mars. So, panel, what are the names of the 2 moons of Mars?
Phobos and Deimos.
Phobos, and what do they mean? What does Phobos mean, and what does Deimos mean?
Oh, I do know.
Fear and
Yeah.
Phobos means fear. That's where we get the word phobia from.
fear, Phobos and
Deimos means
demons.
terror.
Terror. Okay.
Oh.
So it's fear and terror orbit Mars, which, when you think about it, is quite appropriate because Mars, after all, was the god of war. So it sort of fits in with that theme. So let's have a look at one of those in particular, which is Phobos. Now, Phobos, this is the sort of the end of Phobos, if you like. There's some data about it on the right. And you're looking at a crater which is 9 kilometers across called Stickney Crater. Now, why do I think Phobos is a bizarre moon? Well, first of all, do you see these white deposits in the foreground at the edge of this crater? That is very strange. Nobody knows what they are. I don't know if anybody wants to knows better than I. Aaron, any idea what what those deposits might be?
Yeah, I no idea
No,
whatsoever.
don't know what the deposits are, but the streaks they think are. There's two things. One, it's actually scraped alongside something, or it's actually when the rubble was sitting around the top of the crater, it's rolled back and it's gouged the side of the
Which
actual
I don't
moon.
believe to be true. But let's stick
No.
with
It's just one of those theories that they keep on about.
yeah. Let's stick with the white deposits because that's the first strange thing. So let's now have a look at the whole of Phobos. Now, the whole of Phobos has these grooves running along it, parallel grooves, as you can see, all over the place here. And how did they get like that? What's happened to cause those grooves? And again, this is a complete mystery. Now, also, if we zoom in, there are chains of craters running along the length of Phobos. And I've just put some lines on here so that you know where to look. There are quite a few of these chains of craters all in a row. How did they get there? Obviously, several or more impactors have hit the surface in a line. But how did that happen, and where did it happen, and when did it happen? These are all immense mysteries of Phobos. But Phobos is holding another mystery. But before we do that, I just wanted to show you this lovely video of Phobos eclipsing the sun taken from the surface of Mars by the Perseverance rover. It's a bit jerky for some reason. But lovely image. Of course, Phobos isn't big enough to give a total eclipse on Mars, so you'll only ever get a partial eclipse from Phobos. But there we are. Phobos is mysterious, these white deposits, and astronomers have been looking into all of these things about Phobos. And the first thing to say is that Phobos doesn't reflect light like other moons or asteroids do. You normally find with moons and asteroids that they reflect light fairly evenly, and Phobos doesn't. In fact, when the sun is overhead on Phobos, the whole moon sort of glows. It's slightly brighter. This is very, very odd. Also, the surface is sort of granulated like sand, and again, we haven't seen things like this on other moons. So the idea behind this is that actually Phobos is the ancient nucleus of a comet, and those white deposits on it might be ice peeking through this granulated layer on the surface. So we could be looking at an ancient comet nucleus with Phobos. Obviously, it was captured by Mars gravity from where we don't know. I mean, it's always been assumed the asteroid belt, but if it was a comet, Mars might have grabbed it as it came too close to Mars and actually went into orbit around it. So this is really a bizarre moon. Deimos, on the other hand, we don't have very much information about Deimos because this is the best photos of it that have ever been attempted. But you can see from this, again, these white deposits. And also you can see that the craters are sort of semi-filled in on Deimos, as if there's, again, this granulated layer covering the whole thing. So this could be either another comet nucleus, or it could be a bit of Phobos that broke off. So we're looking at one comet nucleus that is split in two, giving us Phobos and Deimos. So this is really interesting. Well, I find it so anyway. And we'll just leave that because that's going to be jerky again. Yeah. Now, before we move to the outer solar system, I just want to really give praise to the wonderful robotic spacecraft that have given us all these fantastic images of data from the outer solar system. So obviously Voyagers 1 and 2, Galileo, which spent quite a few years orbiting Jupiter and studying the planet and its moons in the 1990s. The unforgettable Cassini-Huygens, which spent 13 years at Saturn. And don't forget, it dropped the European Huygens probe onto the surface of Titan, which is the first time we'd ever landed on an alien moon. That's worth a whole talk on its own. New Horizons, of course, went to Pluto and showed us a completely unexpected world at Pluto, and an extremely intriguing one. Juno, which has spent several years trying to understand what's inside Jupiter, so we know a lot more about that now than we did. It's currently on an extended mission, which means it's flying by Io and Europa, but that's been an amazing spacecraft. Don't forget the European Jupiter Icy Moons Explorer on its way to the Jupiter system as we speak. We mentioned this last week. And then lastly, the American Europa Clipper, which is due to launch quite soon to Europa, although they've had a few problems of late because they found out that some of the electronics in it weren't as hardened to radiation as they should have been, and they might have to be in a lengthy delay while they sort that out. But these are all our pioneers, our ambassadors out to the outer solar system. So let's have a look at Jupiter. 92 known moons, as we said. The Galilean moons, obviously discovered by Galileo with his primitive telescope. Not that you need a telescope to see the Galilean moons. You can see them very clearly in binoculars. And they have shown us 4 completely different moons. And the one I want to concentrate on is Io. Now, Io is known as called the shape-shifting moon. Why? Because its crust is constantly being squeezed and stretched by the immense gravity of Jupiter. And this leads to incredible heat building up within the crust of Io because it's constantly being squeezed like a rubber ball. And this has led to the discovery of volcanism on Io. The first active volcanoes beyond the Earth were found on this little moon of Jupiter. And it's about the same size as our moon, but obviously compared to Jupiter, it's absolutely tiny. It's the innermost moon of Jupiter. It orbits at a mean distance of 421,700 kilometers from the planet. Now, it's very close to Jupiter because of that, and it orbits in 1.76 Earth days. It is tidally locked to Jupiter, which means it always keeps the same face turned to Jupiter in the same way that our moon is tidally locked to the Earth. We only ever see the near side of the moon, not the far side. So, Io has more than 400 known active volcanic domes, or what are called pateras. These are sort of depressions or volcanic pits, if you like. But there could be as many as 1,000. The whole moon is basically one giant active volcano at any time. And it's resurfacing the whole moon at the rate of a few centimeters per year. So that gives you an idea of the amount of lava that is spreading across the surface of this moon. So, every so often, every X number of decades, it's sort of more or less completely resurfacing itself. One of the bigger volcanoes on Io is known as Prometheus, and there it is erupting over the limb of Io. I think, if I remember rightly, I think this is a Galileo image. I may be wrong. And here you can see an animation of that eruption, unmistakably a volcanic eruption. I love this little animation of the volcano. Don't forget that because of the low gravity, that volcanic plume is shooting hundreds of kilometers into the sky. So this is really, really a lovely animation. You get an idea of the scale of the volcanism on this tiny moon. And if we look at the thermal map of Io, where blue and black are coolest and red and yellow are the hottest areas, you can see where all of this volcanic activity is. I mean, as I said, the whole moon is just basically one giant volcano, thanks to that intense heat caused by the squeezing of the crust by Jupiter's intense gravity. We've got some shield volcanoes. The largest one on Io is known as Ra Patera. You can see an image of it there. And there's another one called, a smaller one called Loki Patera. They're both shield volcanoes, like, for example, the ones in Hawaii are shield volcanoes. And this black area you can see in Loki Patera is actually a lava lake, and it's actually creating 1 square kilometer of new surface crust per day. And this lake is 200 kilometers. This volcano is 200 kilometers across. And just have a better look at it. So this white area in the middle of the lake is basically what happens is that the magma comes up into the lake and it cools and forms a thin crust on the top, which then generates more crust and so on and so on. So the interesting thing about this is that, as I mentioned earlier, the Juno space probe recently took some wonderful measurements of Loki Patera, and this computer-generated image is what Juno saw. And that lava lake is absolutely glass smooth. It's got a really, really high albedo. It reflects, I think it was 90-something% of the light that hits it, because it's as smooth as glass. And that's what it looks like. So this is a really bizarre moon. And I don't know that it will ever be a target for exploration, because it's so close to Jupiter that the radiation is intense and not a place for humans to go exploring. And I'm not sure why they'd want to anyway. Here's another Patera, Pele Patera. It's much smaller, 28 kilometers across, but it is extremely active for some reason. It's one of the smaller Pateras, but it's incredibly active. And you can see its volcanic plume in the distance over the limb. You can't see it in the foreground because of the exposure of the camera. But basically, that's the plume that is being generated by this Patera, which is very small. But for some reason, this area is incredibly active, much more active than some other areas there. And this is not understood why this is. A lovely image from New Horizons as it flew by Jupiter on its way to Pluto. This little moon produces 100 times more lava in a year than all of Earth's volcanoes put together. And scientists believe that about 30 to 50 kilometers down, there's a global magma ocean, which is feeding magma to all of those volcanoes. So this is a wild moon, and it was completely unexpected. But there you are. Let's move on to Saturn now. As we said, 146 known moons. That could change, and probably will. Just to give you an idea of the distribution of certainly the inner moons, here we see the distance of some of the more well-known moons away from Saturn. And what I'd like to talk to you about is just some of these. But I just wanted to show you a few lovely images of some of these moons that Cassini took. Here you see Titan, Rhea, and the little moon Mimas, which I think is a gorgeous image. This one I absolutely love too. Some of these images I think look a lot better in black and white than they do in color, to be quite honest. A lot of the images have never been processed for color, because Cassini returned, I forget how many thousands of images in 13 years, but as you can imagine, it was a few 100,000 images that Cassini returned. And, you know, NASA and JPL haven't got the money to process every single image into color. So they've only done it with some of them. This one, I think, is very dramatic in black and white, and it's actually Titan and Rhea. I think that's a smashing image. It makes you really yearn to have a spacecraft go back there to get these images in higher definition than Cassini did. Because don't forget, the camera technology on Cassini by the time it got to Saturn was actually quite old. I'd love to see some of these in higher definition. This one in particular. Now, as you can see from this image, there's a lot of noise. If there are any Photoshop experts out there watching, anybody would know how to get rid of this noise, because I think this is a beautiful image. This is actually 3 moons. This is Titan, obviously the big moon in the middle, Dione top left, and I wonder whether you can spot Mimas in the image. If you look at about the 8 o'clock, 7 or 8 o'clock position from Titan, you can just see a little crescent there. It's drowned out by the noise. So this is what I say, I'd love to find a way of despeckling this image to get rid of all the noise. I'm sure somebody who knows what they're doing in Photoshop will be able to do it in a few seconds. and I'm sure it's possible. But I just think this is such. Don't you think this is such a haunting image? I think it's just absolutely beautiful, and I'd love to have that more high definition. This one is one moon passing in front of another. Those being Rhea and Dione. This one I absolutely adore. This is Tethys above the rings there, and Saturn. Again, a very dramatic black and white image. Not sure it would be as impactful in colour, but beautiful image of Tethys and Saturn there. Here we have Rhea with the rings behind it. Lovely shot of the rings there going behind the moon. This one again, absolutely gorgeous. It's Titan, of course, with the rings. You can see very. I mean, the rings look really solid there. You've got to remember that they're not. They're made up of ice, basically, ice particles and ice pebbles and a few ice boulders. But the amazing thing about them, they are hundreds and hundreds of thousands of kilometers wide, but they're only maybe about 30 feet thick. So they're very, very thin. They look a lot thicker here because of the light, but they are very, very thin, the moons of Saturn, the rings of Saturn. Now, this one is one of my all-time favorite images from the solar system. This is Mimas and Saturn. And one of the big surprises that Cassini showed us was that the northern skies of Saturn, the skies in the northern hemisphere of Saturn, are actually blue. So we have a blue sky in the northern hemisphere of Saturn because of various chemical reactions going on. And if we just zoom in on this a bit, there's the tiny little moon Mimas, which you may know looks a bit like the Death Star. I love this image because in the foreground here, you've got the rings. Behind that, you've got the shadows of the rings over the surface of the atmosphere of Saturn. And then Mimas just hanging in that blue sky in the northern hemisphere. I think that's a stunning image. I've always loved that image. What about this one? Anybody know what this moon is?
Clearly a UFO.
Clearly. This is a really weird moon, and its name is Pan.
Oh, Pan.
Yes, they're very same. They're very fellow. Now, you might say, what on earth is that? And that's surely some sort of photoshopped image of something weird. It's not. This is an actual image. I think, again, it's a Cassini image. Has to be a Cassini image. But how the hell did a moon get like this? And let's look at a couple more photographs of it. It's known as the space ravioli.
Oh, I've seen those pictures before.
Right. Yeah.
Not that previous one.
No, the previous one. It's part of the same collection. It is called the space ravioli because it looks like a chunk of ravioli. The idea behind this is that once upon a time, Pan had a ring around it, around its equator, which collapsed onto its surface and built up this sort of. It is a ring around it, basically, on the surface, which is certainly very, very strange. One of the oddest moons in the solar system, but actually it's not alone at Saturn. There's another one called Atlas, which has the same sort of structure. You don't really get the contrast and the relief in this one so much, but it's like a UFO. I mean, but how did this happen? Some people aren't convinced about the ring theory with Atlas because it's just so very bizarre. But unfortunately, these are the best images that we have of Atlas because it was some distance from Cassini. Couldn't really get clear images. But those are two very, very little bizarre moons of Saturn. And then, of course, we come to, anybody know the name of this one?
Oh, it's
No?
Pantheon in it. Hyperion.
It's Hyperion. Now, this has a very odd texture like a sponge. And Cassini only managed to do one photo shoot at Hyperion on its way into Saturn when it initially arrived. So we don't have that many images of it from this distance. Why is it like this? Well, the idea behind this is that the structure of Hyperion is sort of spongy, so that when a piece of rock from space hits it, impacts it, instead of gouging out a round crater, it sort of just sinks into the surface and creates these cylinders rather than craters, because the crust, if you like, yields and absorbs a lot of the impact instead of it being hard and brittle and creating a crater. The bottom of these cylinders, these craters, whatever you want to call them, is filled with you can't really see the color here, but it's a dark red substance that is very much like the tholins that have been found at Pluto, whereby methane interacts with sunlight to form these sort of organic, gooey substances we call tholins. But how that happened with Hyperion exactly, we don't know, because where did that methane come from? So this is a real mystery. But a lovely image of Hyperion there. We're not going to have one like this probably in our lifetimes, unfortunately. So this is the best we're ever going to see of Hyperion. Here's another one. This one is Prometheus, like the volcano on Io we talked about. They have the same name. And this is a lovely image of Prometheus rising through one of the rings of Saturn. And you'll notice it's leaving a black trail behind it. Well, this is ring material. It's not being pushed out of the way by Prometheus. What happens is it's gravitational. The gravity of Prometheus pushes the particles of the rings outwards rather than sort of digging a channel through it, if you like. It's a gravitational interaction. And what happens here, this is the F ring of Saturn. And what happens, it leaves these what are called streamers in the ring, in the F ring, as it travels around Saturn. And they are known as the F ring streamers. You see here the moon towards the bottom. But this is one of the previous streamers that it left. And here are more. There's Prometheus on the sort of the left. And here are some of the ring streamers it's created in previous passes around the planet. And this is a gravitational interaction where the gravity of Prometheus pushes the ring particles out of the way, creating these streamers, which is, I think that's a really, really interesting image. And the ring streamers had been seen as far back as Voyager, but nobody knew what they were. And it took Cassini to unravel this mystery. This is not to be confused with the ring spokes, by the way, in the rings of Saturn, whose origin is still a little uncertain, but seems to be some sort of electrostatic thing, which suspends some ring particles above the plane of the rings. But there we are. Very good image there. This is Titan, of course. Lovely image of Titan. If Lou were here, he could go on for days about Titan, because that's his sort of speciality as a planetary scientist. He's done a lot of work investigating Titan. Then we come to Iapetus. This is a truly bizarre moon. Now, the first thing you notice is one hemisphere of Iapetus is very, very dark. In fact, it's blacker than coal. The other hemisphere is extremely brilliantly white. And there are lots of theories how it got like this. Some of them, I think, are beginning to make sense. But it's still pretty much unknown exactly how Iapetus ended up with one extremely bright hemisphere and one very dark hemisphere. But this is not the weirdest thing about the moon. This is the weirdest thing about Iapetus. It has a ridge running around its equator. We assume all the way, although Cassini's coverage of it wasn't enough to show us all around the equator of Iapetus, but it seems to go all around the equator. This ridge is taller than Everest. It's 13 kilometers tall by 20 kilometers wide. And it runs around the equator. There, and you can see it here. That ridge is so bizarre, completely unexpected. and show you a better image. It looks as if Iapetus was made in two halves and welded together, and that's the weld line running around the equator. It's really strange, and at the moment,
Sort of looks like
it
a
does, doesn't it?
walnut.
It looks very much like a walnut. At the moment, the best theory is that, again, Iapetus had a ring at some point in its early history that collapsed onto the planet, and the ridge is that debris from the ring. But we don't know. It's extremely bizarre. This was a major discovery from Cassini. Show you one of my favorite images from Saturn. Look at this. This is that ridge in close up. And I just think this is amazing. And you can imagine explorers of the far future exploring this ridge, which I'm sure they will one day. Somebody's going to. But I just think, again, this is a beautiful image of Iapetus. Very, very bizarre moon. Let's move on to the other big news at Saturn, which is Enceladus. We've talked about Enceladus before, so I don't want to spend too long on it. There's some data on the right-hand side. But the interesting thing, as we know, is the fountains of Enceladus, which are these plumes of water vapor and ice particles being ejected rather violently into space from Enceladus. And there's another view of it with the plumes backlit. There's a lot of water going into space from Enceladus. Major discovery again from Cassini. And Cassini actually flew through one of these plumes and analyzed what's in that plume. And we'll talk about that in a moment. The thing is, if you look at a map of Enceladus, a temperature map, on the left-hand side is how it should look in terms of temperature. But on the right is actually how it does look. And as you can see, the temperature in degrees Kelvin, 85 degrees Kelvin, is concentrated at the South Pole. And this is where that water is being ejected from. And here's a lovely image I found, a lovely painting that somebody did of how it might look if you were at the South Pole, near the South Pole of Enceladus. These cracks very close to the South Pole is where this water is coming from, and they are known as the tiger stripes. And if we just zoom in, you can see the South Pole in the center of the image there. So very close to the South Pole are these massive cracks known as the tiger stripes. And in fact, they're typically 2 kilometers wide by 500 meters deep. Now, what's the story here? Why are they ejecting such large quantities of water vapor and ice? And the reason is because we think there's an underground ocean on Enceladus. And here's just another shot of that area. As you can see, it's a very complicated terrain. But you can see the tiger stripes sort of running north-south here. And this is what we think the model is. Let me just zoom in on this a bit so you can read it. So basically, you've got an ice cap, which we don't know exactly how thick it is. It may be as little as 5 kilometers at the South Pole, 5 kilometers thick. What happens is that underneath that, there's a global ocean. And cold water falls from the salt, it's a salty ocean, we know it's salty, into this porous rocky core, where it gets heated and it rises again in narrow plumes and interacts with the rocks on the bottom of the ocean floor. This creates hot spots at the seafloor, and they, if you think of the black smokers along the Mid-Atlantic Ridge on Earth, very much like that, geothermal vents, if you like, and they vent this material up through the ocean. At the bottom of the ice cap melts, and this material, because of the pressure underneath it, forces its way through the ice, and all the material erupts out of the fissures that we call the tiger stripes. So this is the current model for what's going on Enceladus. Now, it'd be lovely to think that we could one day go down through those tiger stripes and get down to that ocean. But of course, that ice is probably varies between, I think, 15 kilometers thick at the equator to 5 kilometers at the pole, they think. So one day people will go exploring down there, I'm sure. But it's the most amazing little moon. And it's actually venting somewhere between anything between 100 to 1,000 kilograms per second into space from those tiger stripes. Most of it, 93% of it, up to 93%, falls back onto the moon and coats the moon with this white, snowy material, icy material, which explains why the surface of Enceladus looks so young, why there are so few craters there, because it's being resurfaced all the time by the material from the tiger stripes. And those plumes go up to maybe 40 kilometers or more in altitude above the moon before falling back. And this is one of these plumes is what Cassini flew through. Now, what Cassini found was that some of the particles in the plumes had been in contact with rock, so at the interface of the ocean and the rocky core of Enceladus, and they were able to identify that from the sample. And the idea that you have these things analogous to the black smokers, but in fact calling them the white smokers on Enceladus, on these seafloor, it's very probable that's the case. It's difficult to come up with any other explanation that doesn't involve these hydrothermal vents from the analysis of the plume. We know there were water reactions. They're almost certainly vents because this material has to get out into space somehow. And so there we are. So that's Enceladus. As one final thing. And the material that doesn't fall back onto the surface of Enceladus creates a ring around Saturn. It creates one of Saturn's rings, which is called the E ring. Each ring has a letter. So there we are. So that's Saturn. Just one moon I want to look at with Uranus. These are the major moons of Uranus: Miranda, Ariel, Umbriel, Titania, and Oberon, as you may know from the old Pink Floyd song Astronomy Domini. And want to have a look at Miranda. Now, first look at Miranda, you think, what on earth is going on here? And it is thought that Miranda has been broken up by collisions with other bodies several times during its life, and under gravity the pieces have come back together, but in the wrong order. So it's a sort of a jigsaw puzzle of a terrain. And when we first saw this from the Voyager images, we thought, what on earth is going on here? But it is a moon that's literally been broken up and then put itself back together again in a different order. So you've got some really bizarre features, very few of which are understood. For example, you've got this feature called the racetrack, these sort of grooves. What's that all about? And then you've got this feature called the chevron next to that. What's that all about? These are impossible to explain at the moment without going back there and getting more data. But the most amazing thing for me is that Miranda has cliffs of ice that are 20 kilometers high. You can see them here. And actually, if we just zoom in a bit, it's a bit indistinct, obviously, but these are sheer cliffs of ice 20 kilometers high. Now, panel, any idea if you were to jump off one of those cliffs, any idea how long it would take you to reach the bottom?
About 5 minutes.
5 minutes? Any other guesses?
I can't even imagine.
Probably.
Okay. So do you think the fall would kill you?
No.
Yes.
No?
Yes.
No.
No?
No, it's not the acceleration there.
Yes.
Okay.
I'll say yes.
So yes. Okay. Let's find out. So here's an artist's representation. This is actually taken from a wonderful short film called Wanderers, which unfortunately I can't show you because of copyright music. But in the film, you can see on the left-hand side, going down the sheer face of these cliffs, These cliffs are called the Verona Rupes, by the way. And you see people have jumped off there, and they're sort of free falling. And actually, it would take you 12 minutes to reach the bottom. And when you hit the ground, you would be falling at 124 miles per hour. So that definitely, that's definitely good night Vienna, I'm afraid.
It's not the fall that kills you, it's when you stop at the bottom.
That's true. That's very true. This is slower than Earth's terminal velocity because of the low gravity, but it's obviously still fast enough to kill you. So when you got towards the bottom, I don't know what you do. There's no atmosphere, so you wouldn't be able to use a parachute or anything. You'd have to have some sort of powered way of safely descending the last bit. But anyway, I'm sure people will do it in the far future. So there we are. Let's move on to Neptune. Just one I want to talk about, and this is Triton. Now, Triton is the coldest place in the solar system, believe it or not. It's colder than Pluto. It's got a surface temperature of minus 235 degrees Celsius. And there's some other data about it there. Interestingly, it orbits around Neptune in an opposite way to Neptune's other moons. It has a retrograde orbit. This strongly suggests that it's a captured object. So let's have a closer look at this. Now you see this sort of terrain towards the top left of this image. I'm going to show you another image. Now you probably don't recognize where that image is from. This is actually Pluto. And the two surfaces are incredibly similar. And it's believed that Triton is a captured object from the Kuiper Belt that drifted too close to Neptune and got captured by its gravity. So Triton and Pluto are actually extremely similar. If we go towards the south pole of Triton, now don't forget this is a Voyager 2 image dating from 1989. You see these black streaks across the terrain. Nobody was at first sure what these are. And what they turned out to be are geysers. And if we have a closer look, you can see it's very poor quality, but you can see, I hope, that trail of black material that's above the ground, trailing downwind, if you like, from this active geyser. Now, the idea behind this is that even at the distance that Triton is from the sun, sunlight gets trapped under the ice, or the icy surface of Triton, and the heat builds up and builds up and builds up, and eventually heats up the gases under the ice so much, there's so much pressure that they break through the surface as a geyser. And this was enormously surprising because everybody assumed that a moon like Triton would be completely frozen and dead with no activity on it whatsoever. But it has demonstrated that these outer moons of the solar system, like Enceladus, like Europa, like Io, they're not dead, they are active. There is still energy there, even that incredible distance from the sun. So there are these dynamic processes, even that far from the sun, that are powered by the sun, which is a real revelation. So the outer worlds of the solar system are not dead, lifeless balls of ice. There's activity where we least expected to find it. And we know that Pluto, obviously, is an extremely active world. We see cryovolcanoes on Pluto. We don't know whether they're active or not, but they've certainly been there in the past. So these worlds, it was one of the biggest lessons from our exploration of the outer solar system has been that these icy worlds, they are not dead. There's activity there. So real revelation. Just want to move quickly on now to the last one, which is Pluto. 5 known moons. 3 of them were discovered by New Horizons on its way into Pluto when it did its famous flyby of Pluto in 2015. And here we have those 5 moons in comparison to the Earth in terms of size. So the biggest moon is called Charon or Charon or Charon or Charon or however you want to pronounce it. I don't think there's an agreed pronunciation. I call it Charon. So we'll stick with that because this is my presentation. So there you are. Lovely image of the two together, Pluto and Charon, taken from New Horizons. Beautiful image. Charon and Pluto had the biggest size to planet ratio in the solar system because Charon is half the size of Pluto. And you could consider, as we know Pluto is a dwarf planet, you could consider the system to be a double dwarf planet because Charon is so big in comparison to Pluto. And Charon has a diameter of 1,212 kilometers or 753 miles. It has a surface temperature of minus 230 degrees C, which you might remember is not as cold as Triton, which is a lot closer to the sun, which was minus 235, the coldest place in the solar system. It's got a rotation period of nearly 6.5 Earth days. And it also has an orbital period of the same, which tells you, again, that it's tidally locked to Pluto. It always keeps the same face turned towards Pluto. And it orbits at a mean distance of just about 21,000 miles. This is an image painted by somebody. I don't know whether it's done digitally or actually painted. And I am extremely haunted by this image. I think this is an unbelievably beautiful image, and it gives you some of the idea of the desolation of standing on the surface of Pluto with the huge moon Charon on the horizon. And as I think I mentioned before, I was so taken with this image and how beautiful it is and how evocative and how compelling that I managed to track down who the artist was. I did a lot of digging and found out who the artist was, and I sent him an email just to say, I really love your image. I think it's fantastic, but sadly never had a reply. So there you are. Anyway, Charon, towards the just below the equator, you can see it is scratched by these immense canyons that stretch for hundreds and hundreds of miles. And why? Well, we'll talk about that in a second. The north pole of Charon is coated with something I mentioned earlier, tholins. Now, what it's thought is that gases escape from Pluto's atmosphere and deposit themselves on the north pole of Charon. And these form these organic compounds in combination with exposure to sunlight called tholins. And it is a sort of a red goo, if you like. But these definitely come from the atmosphere of Pluto. And the other very strange thing about Charon is this. This is on the limb of let's just go back one, and we can see. Yeah, if you look towards the sort of the 4 o'clock position, nearly on the limb, you can see this really weird thing. And here's a closer view of it. And what the hell is this? Well, let's put some more detail in a better image. This is actually a mountain in a moat. It's almost as if somebody's got hold of the mountain and pressed it into the ground. But it's not something that's impacted Charon. It is a real mountain, not some sort of space rock. And it's surrounded by its own moat, obviously completely dry. There's no liquid there. But how did a mountain end up in a depression like this? It's extremely weird. If we take just a closer look, looking right down on it now, this is really weird. And it's so weird, but it has been given the perfect name. I don't suppose anybody knows the name of this mountain. It's been named Kubrick Mons after Stanley Kubrick. Hence callback to 2001, A Space Oddity, and the mystery in that film. So I thought it was a great name to give this mountain in a moat, but nobody has any idea how that formed, how it got there. It's really, really strange. So going back to these canyons across Charon, what this indicates that in the ancient past, water and ammonia formed an underground ocean on Charon That then froze, and of course, when something freezes, it expands, and it managed to crack the crust of Charon right across like this, like an eggshell, if you like. This is what astronomers and planetary scientists think, that Charon did have an underground ocean at one time that froze over time and managed to crack the crust as it was expanding, as it froze. So this is a very, very old little moon, and there are other mysteries about Charon as well, which we won't go into at the moment. But again, one of the solar system's most bizarre moons. Just to summarize then, we have this incredible variety of planetary moons, with far more variety than was thought or predicted just a couple of decades ago. The stories are written across their surfaces, and we're only just beginning to decipher those ancient tales written across the surfaces of these moons. They speak of the violent history of the early solar system, of tortured worlds and frequent collisions and rebirth. But they also tell us of their potential for creation in the form of ocean worlds like Enceladus and Europa and others. And perhaps, who knows, they've created life as well. And Bernard knows all about those ocean worlds because he's written a book about them. Just to plug your book, Bernard. We need to get back to exploring the outer solar system and investigate these moons more, because I'm sure there are many, many more amazing tales to be told and understood out there. So there you have it, guys. That's some moons of the solar system.
Right, that's very interesting.
So,
Thanks,
Andy. Yeah, Andy, let me jump in here for a second, because you covered Pluto, and certainly Charon is an interesting object out there, so well worth the list. But I did want to just mention that if you're going to include a dwarf planet, when you're counting moons, you also have to count the one that's orbiting Eris, the two around Haumea, and the one around Makemake.
Absolutely. Yes, but I did want to stick with planetary moons, because I know that there are those incredibly interesting Kuiper Belt objects as well. But we can talk about those some other time. Aaron, if you would like to talk about those at some point, you're more than welcome.
Okay, thank you.
A question from Sandra. Do you know what the temperature would be on Io compared to Venus? I'm wondering, if you landed a craft on it, would it melt the same as what happened on Venus? I'm pretty sure that it would melt, because you have active volcanism there. Even though obviously there's no atmosphere to speak of on Io, but the surface is going to be incredibly hot. So anything landing on Io.
If you look, Andy, Aaron actually looked at it, and it's minus 202 Fahrenheit.
I was wrong.
Yeah, that's the actual surface. Of course, in the volcanoes, you're talking about thousands of degrees.
Yeah, of course.
And to compare it to Venus,
it's hotter.
Yeah, it's a lot different.
There we are.
So yeah, I was surprised that when Aaron put that fact up, that it's minus on the surface. And then you think, well, yeah, I suppose maybe.
But if you think back to that thermal map of Io, there are very few areas where you're not landing on a volcano.
Exactly. But they say that's the
so if you can find somewhere away from the volcano, Sandra, you'll be okay. But volcanism's everywhere, so it's going to be pretty hot pretty much everywhere.
And also, one of the things that we were talking about Phobos and the strange white material. Well, we should know, hopefully, within 6 or 7 years of what that material is, because Japan is sending a robotic space probe, the Martian Moons Explorer, MMX, to Phobos, and it's going to be returning samples.
Fantastic. When's that happening?
So it's launching in 2026, I do believe, and it should be coming back in 2031.
Oh, great!
So it may even do actually two landings on the Phobos. So there is a mission out there to solve that one for you.
Right.
It's like I say, it opens up lots of questions. But yeah, great.
Yeah, I mean, it's been suggested by a lot of people that the way that we could explore Mars more easily would be to land on Phobos first and set up some sort of base on Phobos, and then descend to the surface of Mars from Phobos. which would be a lot more manageable in many ways. So I don't know. But
Yeah, but
Phobos
won't it be a time limited prospect? Because is it Phobos is moving away while Deimos is actually moving towards Mars?
no, it's the other way around.
Other way round, is it? Yeah.
Yeah.
So either way, it's a time
Yeah, but
limited.
it's Phobos will be
It's an
destroyed.
idea,
Yeah, I mean Phobos will be destroyed by Mars gravity, pulled apart in
Yeah.
about 70 million years. So we've got time to explore, just a bit. So no worries. All right, guys. So Steve, thank you for watching. Yeah, glad you enjoyed it. What we're going to do now, Daz, do you want to set your?
Oh, okay. Then if we're ready, let me just.
If you just use this scene, Daz, share the news, put it in there.
It's already set up.
I can't see it. Oh no, it is.
There it is.
Come on, there we are.
Okay, then I've just got to go to.
So Daz is now going to tell us all about what's going on the sun at the moment, because it's been a bit of a quiet week, but I gather, Daz, that there's some big stuff in store for us.
Well, hopefully, yeah. Can you see my cursor?
Yes.
That's the first thing, right? Okay, as usual, the disc on the left is from last Tuesday, where we left it, and this is the disc on the right is today. You can see there's a bit of a gap in there, but these, especially 380, 379, 398, and 96, they have been giving us a display, but unfortunately, it's all been small stuff. We've had 129 flares altogether this week that have been seen and logged. But they've all been sort of like M class, but more C class. We did have a couple M class which were about the 5 mark, M5, but they weren't facing our direction. Although we did have from I think it was 3796, 800. I think it was. There was a flare. It was only a C5, but it was more Earth directed, and it's actually given us it's going to hit us today, but it's going to be very, very light. It's a bit of a side swipe, and it's also it's been predicted, but with very low confidence. In fact, the confidence has dropped a bit because yesterday it was we're probably going to get a G1, which was about which is a G1 geomagnetic storm, which is the lowest level of a G1. They were predicting probably 30%, but now the time has also moved back because it was supposed to hit us this morning. Because if you remember, anyone who saw it, I had a warning, well, not a warning, but just a bit of information that if the Polaris Dawn had launched this morning, it would be launching into a very minor geomagnetic storm. But considering they're studying radiation, they probably would have loved it. But I've checked, I've waited until the very last minute to finish this because it's moved backwards. It's moved towards the 18th, so it's more towards the 18th. And it is actually running into the 18th, but also it's changed that there is sort of like a double peak tomorrow. So they will, if they do launch tomorrow, they still will be launching into space that is enhanced with more radiation than we normally have. It's not going to be a problem for them, but it's just one of those things. And considering what they're going to be studying, hopefully if they can get their instruments up and running, they can do some measurements from that. But other than that, there's been very little going on. I'll just move on. This is the sunspots that we've got on there today. As you can see, we've got 5. And it's and you see 5 of them are got BG, so that's beta and gamma complexity going on, magnetic complexity going on. And of course, they're marked in red because these are the ones that are going to basically give us anything big that's going to actually erupt off of the sun's surface. So these are going to give us, could give us some big flares. You can see 4 of them are growing, one's declining in strength. but these can change at any time. And if you cannot even have three letters in there. So once you get 3 letters, you know you've got a big player that could kick off. But I'll just leave that there because, and I've lost my cursor. There he is. Right, here we go. Now, this is the normal one that we saw in shoot. This is a week in 40 seconds. I've got lots of them. Here we go. I'll just start it so you can actually see it. You can see all this stuff going on. You can actually see lots of things going on. There's flares. There's even lifts off of filaments. You can see these sort of like smoky whiffs that fly off. There's some prominences down in sort of like the 8 o'clock region. And what Roger was on about comes towards, well, it's actually today that they're actually on the surface, on the rims of the edge. There it is. You can see on the 9 o'clock, that big region with all the arches. I will be showing you a bit later on, a bit close up on there. But what was actually happening there was absolutely beautiful. And then also, if you look around sort of like between the 2 and 3 o'clock, there's another one here which connects. You can see there's a thin filament that connects around here. Again, I'll show you a close-up of that later. Again. So this will give you an indication of all the flares. You can see some of the magnetism flipping around, flying off. You can see the eruptions. Again, because what I was talking, Andy was talking about, is that you can see these big flares. You can see this region here. This is the one that's given us some nice flares. There should be another one coming up soon, and you'll see the spikes, refraction spikes on there. I think we've just gone past actually. There we go. And you can see that down here, 800's doing the same. So we've been getting these flares, but they're nothing really to talk about. But all the action that we, in fact, most of the action, again, we've reverted back to this situation where the action is happening on the far side of the sun, as Roger calls it, the dark side. So it's, yeah, it's basically most of the action again is happening, and we'll see this in the coronagraph image in a bit later on. I hate the delay on the cursor. So here we go. Now this is remember this is the magnetism one. This is 171 Armstrong's wavelength, and again you can see the lines switching from different spots to different regions, flowing away. You'll see some of them break, and what's coming around on the eastern side and what's disappearing on the western side. This is all the magnetism, and you can see the actual field lines. And here it comes on the eastern region. And you can see there's something big coming around, and we'll talk about that in a second. So we'll just let this run. As you can see, it's coming around. We've got some nice activity going on here, but there's some more to come, and I'll show you in a minute. Right, here's your coronagraphs. As you can see, this is a whole week. You can see things flying off, but most of the major ones were on the far side of the sun. So that was one on the far side. So that one was actually on the near side, but it was off to the west. There is one more, the biggish one that will come and sort of like about the 7 o'clock region. And that was the one that is arriving with us tonight. So there we go. In fact, in some of these, in different wavelengths, and actually you can see some of these were actually blowing smoke rings, which was quite interesting. So yeah, we'll just let this run out. I know some of you like these pictures. Right, so I'll come on next. Now, this is what I was talking about. This, you're looking at the very top panel. You can see at the top, you've got plasma density. So you're talking about radiation and things like that. And then at the bottom, you're talking about radial velocity, which is basically the space wind. So what we're looking at is this green line. Now, this was the peak was around here, so it would have hit us during midday, but it's moved this way. And as you can see, it's a double dip. So tomorrow, now this isn't very high. So like I said, we're not going to get, even if we did get aurora, well, it's very likely that they'll be right up in the Antarctic, in the Antarctic. But as you can see, they'll be launching about here, so it'll be low, but it will be increasing during the day. And this is the Met Office. So this is for the UK. NOAA's predictions are slightly different. So this is what we're looking at. They will be launching it sometime into some enhanced radiation. But as I said, it's not going to be, they're not going to melt in their seats or anything like that. So don't worry about that. So that's what we're expecting. Now, this is what I was on about. Remember, I've shown you these pictures before. On the right-hand side and the left-hand side, that is the side that's facing Earth. So that is the side that's coming around. All this in the middle in the orange is what's coming around from the far side. This here on the right-hand side is the eastern limb. That's the western limb. So this is the stuff that's disappearing off the face. This is the stuff that's coming on. Now look at this massive black active region coming around now. Now it's going to be, obviously it's going to be split up into several different regions, but this is one hell of a big active region that's coming. In fact, actually it's dissipated a little bit because the spot that's above it, it was actually joined to the other day. So this was an even bigger spot, but it's obviously broken up a bit. But what you do is I'll break this down into different regions, but this is a huge area coming round, and this is what's given us that all those arches that we could see on the far side. So I just thought I'd like to put that in there. The last thing is, and this I really left it to the very last minute before I actually put this on here. You can see that it has started to climb. I'm just going on to another device and I'm going to have a look at the new data, and yes, there is definitely an inclination. It's actually rising. So yeah, it's we're getting to the stage where the readings are beginning to go up, but we're not going to get into anything really big on this. So I just so yeah, so there was, as you can see, there is a slight it's slightly going up. You can see at the bottom in Heartland it even went to green, which means it's active, but then it dropped down again to unsettled. But this is the next 3-hour block will appear very soon, I presume, because it's every 3 hours, and I think it's 9 o'clock. Not 9 o'clock. Is it 9 o'clock? 10 o'clock or something like that. Anyway, so yes, things are actually picking up. Now the last thing, let's have a look. Which one do I want? I want that one, I think. Right, now these are those regions that I was showing you. So this is on the eastern limb. Now look at that up the top. And all the action is also going back. But you can see they're virtually linking each other. But you can see the plasma being drawn up. And now where this came from, I do not know. I don't know whether that's going away into space or whether it joined from further down. I'm pointing. Why am I pointing? You can't see my finger. So yes, again, what I'll do is I'll start it again so you can see it. There you go. This is some of the stuff that's actually coming from beyond the eastern limb. So I mean, that was absolutely fantastic. And then on the right side, this is what's disappearing off on the western limb. I'm apologize that it's a little bit dark. If I can get it started. Here we go. So as you can see, you can see this arch building up. It's actually on the disk and it's moving towards the west, so you can actually see it coming up in profile. But then you can see it's actually connected to this big sunspot here, this big active region here, and there is a connection. Look at that stuff flowing backwards and forwards. So the sun is very, very active. Now, the last thing I'm just going to talk about is that as regards the sunspots is that the sunspots we have got now, every day this week we've been counting about between 170 and 180 sunspots. So again, we are still quite high. Next week, hopefully, we'll have the results for this month, and it'll give us an indication of whether or not we're still climbing or whether or not we'll be dropping down. But I will say about 10 days ago, we were averaging over a couple of days, well over 300 sunspots. So things are still kicking off. So we won't know until a bit later on whether or not we've actually reached the peak. So there we go. So hopefully that tells you what's going on.
Thank you very much, Daz. Wonderful as always. Nice to see what's happening. If you have any questions for Daz, don't hesitate to put them in the chat. But I think the bottom line is no immediate
not at the moment, but of course, all it takes is just one flare with a big CME, and everything could change.
Absolutely.
But yeah, this year, I mean, this week was over the last 2 weekends prior to the last one, we had alerts on both weekends, but this week has been very, very quiet. So yeah, but that can all change.
Absolutely. Just to finish off, just want to have a very brief chat about the big space exploration news of the week. This whole business of the Boeing Starliner, and I had a question from Jack Martin, and he basically asked if they're really thinking about the health of the astronauts, Butch and Sonny. Now, don't forget, they flew up to the International Space Station on June the 5th, expecting to stay for an 8-day stay on the International Space Station. Now, they're probably not coming back until next February because of the problems with the Boeing Starliner. After a prolonged period of analysing the problems with the thrusters and the helium leaks on the Boeing Starliner, NASA have made the decision that they don't really trust the Starliner to get the astronauts back safely. So they're going to stay on the space station and come back at the end of the new crew mission. They launch in September, and they're going to return with Butch and Sonny on the SpaceX Dragon in February. And as far as the astronauts go, you have to remember that the astronauts who carry out prolonged periods on the International Space Station of many, many months, or up to a year, as it's been on a few occasions, they have to go through a rigorous training health program to be able to handle a space voyage of that duration. Butch and Sonny were not expecting to stay that long, obviously, on the space station. So in terms of their health, I was reading a report the other day that said that Sonny Williams, she is already suffering from this, coincidentally, this ocular eye problem that the Polaris Dawn mission is going to be researching, where prolonged periods in microgravity affects the eyes quite badly. One of the symptoms is that because of the microgravity, your eyeballs actually don't maintain their spherical shape. They start to get out of shape, which causes all sorts of eye problems. And I was reading a report that I haven't seen anywhere else. So I'm not saying it's definite, but the report was saying that she is already suffering from eye problems from prolonged exposure to microgravity. So I wonder whether anybody has got any thoughts about this. I don't want to get into the wheres and wherefores of the mission exactly, because we could talk for a long time about that and bore our audience with it. But has anybody got any immediate thoughts about the decision by NASA to not bring the Starliner back with the astronauts? The Starliner will leave the space station empty and return to the Earth without the astronauts because it's not trusted to bring them back safely, and safety, obviously, for NASA is the most important thing. So anybody got any thoughts?
Andy,
Yeah.
just like to say on that, not so much the health problems, but actually bringing them home. Of course, when Starliner leaves uncrewed, there will be a time before Crew 9 Dragon gets to the ISS when there won't be a lifeboat for Butch and Sonny. If anything major should happen.
Sorry.
Yeah, go on, Daz.
I was just going to say that's why they're keeping it up there for the moment.
Yeah.
Because it is their lifeboat.
Yeah.
But as they did say, they were talking, or it has been mooted, that what will happen is that when Starliner does leave, once they've sorted out the command to actually undock, then and it leaves, is that Butch and Sonny would still come back on the Dragon, and they would strap themselves to the cargo pallet that is underneath
right,
the 4
okay.
seats.
Yeah.
So, but that's the only thing they can do.
Yeah.
The suits that they were using, of course, there's only one suit on there that's compatible with the Dragon, but of course, with there only being 3 or 4 seats, it's basically won't, because there is a Dragon suit up there, and that's for the lady, I can't remember her name offhand, who went up with the Russians, and they sent a suit up for her just in case she does have to return on a Dragon, because of the problems that the Russians have had in the past with their ships. So there is one suit up there, but whether or not it'll have the connections that it can be plugged into whatever it's plugged into to make sure it's pressurized and all this stuff, and but so one would have to come back in some sort of, I suppose, one of the Starliner suits, which of course, but they won't be actually pressurized or anything like that. But that's the idea. But it also means that the Starliner is going to stay up there until it's safe enough that they can consider they can get rid of it. Because, like you say, Crew 9 can't go up to. Well, actually, no, I was just thinking that can't be right, because if they're going to send up Crew 9. They've got to get rid of the Starliner before Crew 9 can go. Whatever happens.
There's only the 2 compatible docking ports, isn't there?
That's right. So they've got to get rid of the Starliner. But of course, I think they're going to try and minimise the amount of time that there's a chance that anything can go wrong.
As I say, if there is a major incident, then how are they going to get out? And like you say,
while it's still there, that is their lifeboat.
Yeah, that's right.
That is their lifeboat, and they've said they will use it regardless.
But there is, of course, the Crew 8 Dragon currently docked with the ISS. So, people have said, well, why can't they come back with Crew 8? And the reason is because although the Dragon has got a maximum capacity of 7 astronauts, it's only certified at the moment for 4 seats, not 7. So they can't come back with Crew 8. So they've got to wait until they send up 2 astronauts on Crew 1, and they come back in the other 2 seats.
I'm just going to say Starliner's due to depart about the 6th of September. Is that right?
Yeah, and because the Crew 8 aren't scheduled until to go up. And like I said, they're going to have as small a gap as possible where they've only got one ship up there. But this is why I said what Andy was saying is true. They've only got 4 seats, and this is why they're saying if something major did happen, the other 2 crew members would have to strap themselves somehow to the cargo pallet that's underneath the seats. But that was so they would try to minimize that as much as possible. But the one thing that keeps coming to my mind is the batteries on this thing.
Oh yeah,
they were only certified for 45 days, if I remember rightly, and they doubled that. Now, why have 45 days if you think that the batteries are going to last 90 days? I know they're being recharged by the International Space Station, but these things still degrade. The longer they keep it up there, of course, there's more chance. I mean, it might not happen, but the degradation in the batteries themselves, that when the Starliner does leave, it will lose power on the flight down, and it could end up. Can I just
say a question from Sandra? I wonder why NASA wouldn't have something prepared in place in case of anything happening. That, Sandra, is the $64,000 question. That's a very good question. I also have another question. Why the hell did they allow 2 transport systems, the Starliner and the SpaceX Dragon, that do not have compatible spacesuits?
Good point.
I mean, why isn't there a standard for spacesuits when they have 2 systems where one of those systems might fail, as it has, And they've got to send up there for, as Daz says, another spacesuit, a Dragon spacesuit with Crew 9. That's assuming that the one is in place on the space station actually works. If it doesn't work, they've got an enormous problem.
The trouble that they've had with the spacesuits on the station, I mean,
yeah, well, this suit has been sent up quite recently because, like I said, it's for the female astronaut who went up with the Russians. They have tested it, so they know it works. So that is not a problem.
And Sandra says, yes, it doesn't make sense. You're quite right. It makes no sense. And it's egg on face all around, both at NASA and Boeing, for allowing this situation to arise as it has. John, have you got any thoughts on this?
Well, as far as their health is concerned, they will be monitored to the nth degree from the ground. There's flight surgeons on this space station, so they're perfectly safe up there for the duration.
Yeah.
And it's all going to be monitored. They've both been up before, know what to expect. They're probably enjoying the overtime.
Yes, that's right.
Yeah.
And it does mean, of course, that they've got to have Christmas without their families.
Well,
that's right. Yeah. One of the other things was you were talking. I mean, if Sonny's eyes do get really bad, how are they going to cope with that?
I know.
Because it can lead to blindness. That's the ultimate thing that will happen.
Yeah.
But also, I mean, talking about the future, does this mean that we're going to have a Dragon sat on a launch pad somewhere, waiting to go, just in case something like this happens again with a Dragon?
Yeah, but don't forget that NASA recently signed a contract with SpaceX to do exactly that.
Yeah.
They've actually contracted SpaceX to have a lifeboat, if you like, on standby.
But then again, you're in the same situation you are with the Starliner. Batteries and other things have a shelf life, so you can't have it sat there indefinitely. I mean, we know they could get one ready within because they've got 4 or 5 Dragons.
Yeah, they have.
Whereas Boeing have only been able to buy 2, and both of them are, not that good.
They've got 4 Dragons at the moment, and another one which is going to be ready really soon. So
that also takes away this business about that you need more than one ship, unless they actually find a design fault with all the Dragons. You're not going to fall into that situation.
Yeah, absolutely.
But it's. I mean.
Well, let's just.
I don't want to get into the politics of this, but there was lots of contradictions, and one of the things I don't like is that in the last 3 press conferences, Boeing have been absent.
Yeah.
I don't like that.
That's a good point. It's definitely a good point.
And some of the things that were said in the last one, with especially Mr. Nelson, were all contradictory. And it doesn't make sense. Some of it just does not make sense. But let's get this crew back. If the Boeing Starliner is going to come back, let's get it back, and then worry about the politics afterwards.
Absolutely. Can I just bring in Aaron? Aaron, have you got any thoughts about this?
No, just what it tells me is, yes, we're making all kinds of progress going into space. We've now got contractors that are flying their own spacecraft. That's all wonderful. But this just brings home the fact that it's still very dangerous and unpredictable.
Yeah, absolutely.
Definitely.
Yeah, space is harsh. It won't give you a second chance.
Words out my mouth, does.
Yeah, it won't give you a second chance.
I mean, it's I think people are lulled into a sort of a false sense of security by TV sci-fi, where space travel is routine and not really that dangerous, and you can get in a starship and fly across the galaxies if you're getting on a bus. This will never be the case. Space travel will always be intensely risky and intensely dangerous. All you can try and do is minimize the risk as much as you can, of course. But it's never going to be an easy business, and things like this will continue to happen. So I agree with you, Aaron. It just underlines that in terms of what we're doing in space, it's still very, very, very early days. We've been sending humans into space since 1961, but it's still incredibly dangerous and unpredictable. and it will remain so for the foreseeable future.
I mean, until we build something like Aaron's got behind him, then until we can actually beam up and down, then we're going to have to use rockets and capsules, unfortunately. So
well, the transporter's never going to work for some fairly basic laws of physics.
You don't know, Andy.
Yes, I do know. I do know. Yes, people always say, "Oh no, you don't know. It could happen in the future." It can't happen. It cannot ever happen.
And
everybody wants their body ripped into millions of pieces and then reassembled.
It's not the ripping apart of the bodies in the Star Trek transporter that's the problem. I'm prepared to admit that might happen, but the fact is, if you convert a human being to energy, the amount of energy locked up in your cells is equivalent to 3 Hiroshimas, which would put a dent in the wall of the transporter room just a little bit. So the way it's meant to happen on Star Trek is never going to happen. It cannot happen.
Yeah, but remember, the aliens are going to come and show us how to do it.
Yeah, sure.
And you can't change the laws of physics.
No, that's right. Absolutely not. So, so there we are. But the future is a long time, and perhaps they'll find another way of doing it. But at the moment, we are stuck with things like the Boeing Starliner. God help us.
There's just one more thing I would like to say, and this is a dig at Mr. Nelson. Is he rewrote history as regards the Challenger and the Columbia disasters?
How so, Daz?
Do you want me to go into it? He was basically saying that the problem was that the systems were not in place for people to bring problems that they've seen to the managers. On both the Challenger and they were warned about the O-rings, and they've never been launched that cold. And it all goes back to this one phone call that was this telephone call that they had the night before, where they were bullied. The engineers at Thiokol or something like that.
Yeah, Thiokol,
they were bullied into passing, saying yes. That and it happened both at Thiokol and at NASA. NASA were bullying the managers at Thiokol, and Thiokol bullied the engineers to override it all. And the biggest giveaway on that was NASA wanted that in writing. They had to send a telex, and that's never happened before. And then with the Columbia disaster, they were warned that the strike could have caused the hole. They were asking for them to turn around some of the spy satellites, which could have checked the wings of the thing, and again they refused it. And it was the Boeing massive computer that said everything was fine on that Columbia. He rewrote history there. Yeah, and that did really irk me. I'm afraid I did say have some harsh words.
Yeah,
but
so
there
you are. I mean, so there you are. Okay, well that's it. Listen, guys, we will return at 08:15 tomorrow for the launch of the Polaris Dawn mission. We hope you can join us. It's going to be a thrilling mission. We're going to try and bring you as much live coverage of the mission as we can, depending on what NASA and SpaceX transmit, obviously. We will bring you as much of the transmitted coverage of that mission as we can, depending on what time it happens, of course. But certainly the spacewalk is something we're all looking forward to. Anybody remember, apart from spacewalks outside the ISS, what was the last mission to have a human spacewalk?
Could it have been an Apollo? Didn't they have to recover some... Or am I thinking of something else? They recover some film or something.
Not including the ISS?
Not including the ISS. Was it Apollo or was it Gemini?
Apollo did spacewalks.
Yes, they did. They had to retrieve the cameras.
The film, the film.
Didn't they?
Oh, that's right. They did, yeah. So we could be looking at, the first spacewalk in 50 years, apart from the ISS.
Were they not on Mir? Did they not do any spacewalks on Mir?
They did, yeah.
Ah, yes. You're right, John.
But also,
and I suppose, also they spacewalked in the shuttle when they did the Hubble repairs.
Ah, yes.
Oh, yeah, that's right. Yeah, that's true. Well
Yeah.
remembered, John. Yeah, that was. That's when they
Yes,
did.
of course, the Hubble
So that was a Shuttle and Hubble.
Yeah, Steve Wagstaff says Hubble, yes. So that could be the last one.
That's a test
Well
by
done,
the way, Andy.
Sorry?
That's
Yeah.
a test, not Steve.
Yeah.
Oh, and also last week a question
test,
was
yes.
asked. Had a crew ever returned on a different
I was saying that.
capsule or something like that? Well, the Americans didn't. If you remember, the Russians did when they had all those coolant leaks.
Right.
They sent up a separate vehicle to rescue them, so they did return on a different vehicle. They didn't return on a vehicle that they arrived on. So the Russians did that as well.
A film that we need to watch is, of course, Marooned.
Oh, yes. I was watching that not so long ago, actually. Marooned. Gregory Peck.
That's the one, yeah.
Yeah, great film, actually. I saw that in the cinema.
Why would we watch a film about a colour?
Sorry?
Why would we watch a film about a colour?
Marooned.
Yeah.
Wasn't The Colour Purple a follow-up?
Hey!
Yeah, absolutely.
There's always the one.
An old yeller. Anyway.
Yeah, I saw that at the Ritz Cinema in Southend-on-Sea when it was in the cinema. And I remember being absolutely disgusted because the sound system in there was so bad you couldn't understand a word of the dialogue. And I went the whole film not having a clue what was going on.
I remember I don't know why, but I always remember the scene where Gregory Peck is talking to the president from his car.
Yeah, that's right. That's right. Yeah.
Well, we'll have to do a sci-fi film one day.
Yeah, we'll have to start reviewing some sci-fi films for you.
Yeah.
And it'd be nice to go back and look at some of these older sci-fi ones.
Yeah.
You know, not the Star Trek and Star Wars crap, but the hard sci-fi ones.
You mean the proper stuff?
Yeah, the proper stuff.
Have you seen the timeline that's out on various social media things of where we are in the science fiction film timeline? Because we're at the moment just around Solent Green.
Oh, really?
Yeah.
Lovely.
Oh, get the mincer, right?
Indeed. Take the pill.
Yeah,
come on, Grandad.
Absolutely. Can't be a bit of Soylent Green. So there we are. But wasn't who was it? Charlton Heston in that?
Yeah.
Who was also, of course, in Planet of the Apes.
Mm-hmm.
That's right, the original one.
And he was in the Adronomus train, wasn't he?
Oh gosh,
Can't remember that one.
No, that
wasn't it?
No,
oh, I thought it was. No. Okay, my bad.
So there you are. And he ended up a complete right-wing NRA gun nut in the end. But there you are. How the mighty fall. Anyway, viewers, we're rambling, but we'll have a think about having a chat about some old sci-fi films because that'd be good. So, 8:15 tomorrow. Be there or be somewhere else. It'd be lovely to see you if you could join us for the coverage tomorrow. Don't forget the date and times are always subject to change with space missions, but at the moment things are looking good for an 8:38 BST launch tomorrow. But we said this last night and it didn't happen. So let's hope that it happens tomorrow. But anyway, keep your eye on the channel. We'll see you tomorrow. If we don't see you tomorrow, if you can't make it, then we'll be back next Tuesday at normal time, where we'll have some more fun and frolics with the universe. So I'd like to say thank you to John. Thank you, John. Thank you, Aaron. Thank you, Roger. Thank you, Michael. Thank you, Daz.
Thank you.
And lovely to see you as ever, gentlemen.
Once again, thank you.
And if we don't see you tomorrow, viewers,
thank you, Andy.
That's my pleasure, of course. Shucks. Then if you don't see you tomorrow, viewers, we'll see you back here next week.
Yeah, Belarus is still scheduled for tomorrow morning at the moment.
Yeah, at the moment it's all looking good for tomorrow morning. So I hope to see you tomorrow morning, but if not, have a fantastic week, viewers. Thank you so much for being here. Don't forget to like and subscribe and comment. That really helps us. And thank you so much for watching. We do enjoy talking to you. So from all of us at Space Oddities, take care of yourselves and bye-bye.
Oh, and also, if you've got any questions, don't forget to ask them on Facebook.
It's still going on. Sorry, what were you saying, Daz?
I was just saying, don't forget to ask questions in Facebook if you've got any questions.
Oh, yes, thank you. Yes, don't forget, if you've got any questions you'd like to answer us, put them in the Your Questions Please chat in the Facebook group, and we'll answer them on the show.